All right. So on page 207, this is section 3.1. All right, we are trying to use one-to-one in order to solve this problem. So what we want to look at is that if these bases are both the same number, that means they're one-to-one. That means this exponent up here, the x squared minus 3, must equal to 2x. So we are allowed to drop off the e's because we want both exponents to be exactly the same. And as soon as we see this hopefully will have a flashback to Algebra 1, and we've been doing this year as well. This is a quadratic because of x squared, and the rule to solve a quadratic is you must get the quadratic equal to 0. So we got to subtract that 2x over to this side and set this equation equal to 0. So then we have to look to factor this problem and get our factors. So again, when you factor, you're supposed to take 1 times -3 and stick it on this side. Take your -2, stick it there. And then you're going to ask yourself, what are factors that multiply to give me -3 and add up to -2? So I hope you can all get that would be -3 times 1 is -3, and -3 plus 1 is -2. So we come in here and we write those two numbers in here with our x's. Now, if this would have been any number other than 1, if there's something here other than 1, you got to put it under the 3 and the 1. And you set both of these equal to 0, and you solve them. So we get x equals 3 and x equals -1, and there's our two answers for 47. Does anybody else have any questions you want me to go over off of anything? Can you do the graph question on the back of the last test? Okay. Let me get the graph question on the back of the last test, and I'm going to take a picture of that. Are you talking the one that has the equation 3 over x plus 5? Okay, so I got to get my camera, take a picture of it. And I'm going to try to zoom in a little more on it. All right, I'm going to take a picture. Okay, so some of you didn't read directions. The graph, you're supposed to graph this thing and put none in a blank if the answer's none. If there isn't one, you're supposed to put an answer in it. Well, when I look at this problem, I have x plus 5, and there's no way for me to get rid of x plus 5. So we're supposed to know that vertical asymptotes occur where the denominator equals 0. So I'm supposed to take x plus 5 equals 0. So where x equals -5, that would be my vertical asymptote. Holes occur if you can reduce this factor. Like if there would have been an x plus 5 up here in the top, this would reduce with this, then that hole, this would move down to a hole. Holes happen where factors reduce, but this does not reduce, so it's not a hole. It is a vertical asymptote, and since nothing reduces, there is no hole, so we put none there. So over here, I'm going to go -1, 2, 3, 4, 5. I'm going to go ahead and draw a vertical asymptote right here down this -5 value. Go ahead and put -5 there. So what that tells me is the domain. The domain can be anything except, if it was a hole doesn't work either, but it's anything except the x values that are up here. So my domain is going to be -∞ to that -5, and I got to jump over -5 and go to infinity. Horizontal asymptote. So the shortcut is the top exponent is 0 because there's no x. The bottom one's 1, so the top is less than the bottom. So if you study the notes and do it, that's y equals 0. So I'm going to put a horizontal asymptote on the x-axis. Okay, so then I'm going to find the x-intercept. So when I do the x-intercept, y is 0. So I plug 0 in for that y, and I get 3 over x plus 5. I got to multiply that x plus 5 over times 0, which is 0. Does 0 equal 3? And I hope we all know the answer is no. This is not true. So that means there isn't any x-intercept, which means this graph does not touch the x-axis. So like above, the range is everything except 0. So I'm going to say -infinity to 0, jump over the x-axis, and go 0 to infinity. Okay, then we're going to keep going here. I'm just trying to get this thing back over here so I can see it. There we go. And then the last thing is the y-intercept. So I'm supposed to plug a 0 in to the denominator. So I plug a 0 in right there, which 0 plus 5 is 0. So this y-intercept is y equals 3/5. I accidentally hit that button. So I come over here at about 0.6, and I'm going to put a dot. Oops, I'm going to blue. Yeah, that is blue. I'm going to put a dot there. Now I can do a t-chart. And I can plug in some x values over here. I can plug in -1, -2, -3, and -4. I can't plug in -5 because that's an asymptote. So I'm going to get one that gives me real easy numbers. If I plug -4 in down here, I put -4 plus 5, that's 1. So 3 over 1 is 3. So at -4, I'm at 3. And then I'm going to try to plug in another number that's an easy number. If I get a 3 over 3, that gives me an easy number, right? So 5 minus 2 is 3. So I'm going to plug in -2, and that would give me 1, because if I plug -2 in there, that's 3 over 3. So at -2, I'm at 1. And because of my asymptotes, this is enough to graph a fairly accurate graph. Now, if you have this line touch this axis, or this up here touch this axis, this line, you lose a point. Now that's half the graph. I got to go on this side and plug in some numbers over here. So again, I like having some numbers that are easy. So if I put -6 in, I'm going to put -6 in, I get a -1 on the bottom, which 3 divided by -1 is -3. So I'm going to go down 1, 2, 3, and put a dot there. And then I want this to be a -3, so I would plug in -8 minus 5 is -3. So let's see, that's 5, 6, 7, 8, and that would be -1. So this is good enough to draw this side of it. And again, if you touch the asymptotes with your graph, if that crosses this line up here or touches that line, it would be wrong. So does anybody have a question on that one? Okay, does anybody have anything else you want to see? Okay, there's only 5 of you, so if you're good, I want you to text me good. If you're all 5 agree that you're all good, we're going to call it a day. There's 1. There's 2, 3. I got 3. There's 4. There's 5. So we're all good. So I'm going to call it a day. I hope you have a great weekend. Stay out of trouble. Do what's right, not what's popular. And I will see you guys Monday and Tuesday.